Why do scientists need to measure infrared light? Isn't visible light good enough? Humans can see lots of details with our eyes, so what does infrared light add? Here's an example of what our eyes can see. There are two lines on this graph, also known as spectra, which show the amount of light reflected from green and red paint in the range of colors that humans typically can see. Green paint is best at reflecting green light, and red paint is best at reflecting red light, just as you would expect. The two spectra look very different, so in this case, you don't need infrared light to tell the difference between red paint and green paint. But take a look at this graph. The blue line and the green line show the amount of light reflected by the volcanic minerals olivine and pyroxene. Scientists need to be able to tell these minerals apart, but on this graph, they look almost identical. You would have a hard time telling the difference between these minerals using just visible light. Now we've changed our scale so that everything from our previous plot of the visible range is squashed over on the left part of the graph to make room for the infrared part of the spectrum. When we add infrared light, we can graph and note a lot of differences between these two minerals that looked identical in visible light. The lines no longer sit on top of each other. This is why scientists need to add infrared light. It helps them tell the difference between things that otherwise would look very similar. Let's see a few more examples of how using infrared light can highlight differences in things that otherwise would not be so obvious. This is a true color satellite picture of Los Angeles. This is what a person would see looking down from space. The city appears in different colors of brown and green. But when you take pictures using infrared light and make a false color picture, the image changes. The purplish patch that appears over on the left is an area where a lot of the plants were burned by a wildfire. It was not very obvious in the visible light picture, but when you make a false color picture using infrared light, it really shows up. Here's another example. The Mastcam-Z instrument on the Mars rover Perseverance can take pictures using visible light or infrared light. This is a picture taken in the lab on Earth of a bunch of different rocks. There are some differences in just visible light. Some of the rocks are reddish, and some are whitish, and some are gray. But when we use information from infrared and visible filters together, we get this really bright false color picture with different minerals appearing as different colors. Here's another example from the NASA Avaris instrument, which looks down at the Earth from an airplane and takes the spectra of the things that it sees. This is roughly what human eyes would see. Everything is sort of brownish. Now, watch what happens when we use the shape of the spectrum to make a false color picture to highlight different minerals. Suddenly, all these different colors jump out. It is now possible to see the difference between minerals that otherwise would be invisible. Scientists do the exact same thing with data from Mars. This is a satellite picture of the Neely Fosse landing site candidate on Mars. These bright colors are minerals that would be invisible to the eye, but really light up when you use spectra with infrared light. That is why scientists use infrared light.